Okay, we're going to go ahead and get started. Welcome. You'll find out what this is in a minute. Welcome to our talk on our IoT vision and roadmap. We're going to be covering everything across Azure IoT, Windows IoT, as well as Azure Sphere. My name is Sam George. I'm the director for Azure IoT.
Good afternoon. I'm Rashmi Malviarchi, Group Program Manager for Windows IoT.
Good afternoon. I'm Galen Hunt. I'm the Managing Director of the Azure Sphere program.
Great. So let's start with the perspective, Microsoft's perspective on IoT. A big area of focus for ours is that the recognition that while IoT is a wonderful technology and a wonderful technique that can be applied to lots of different problem domains, fundamentally it's a business revolution. The impact that it's having across industries is very, very significant, and for developers that presents a very unique opportunity. As far as, there's a tremendous amount of value in IoT, especially on the sort of commercial side of IoT, and there's a huge opportunity right now for developers because many of those. Hi there. Can you increase the volume in the back? Sounds like some folks can't hear. Better? All right, great. Is a business revolution. And it enables something we call a digital feedback loop. And that's not a fancy marketing term, it's a real thing. So let me explain what the digital feedback loop is. It really connects products or assets to companies, to businesses, enabling business transformation. What's interesting and why we say it's a loop is that it is not a one-time thing. And I thought it would be worth walking through one of our earliest customers, ThyssenKrupp Elevators, to see what their journey through this digital feedback loop looked like. So the first trip through this feedback loop that ThyssenKrupp took was simply connecting. By the way, sorry, for context, ThyssenKrupp Elevators manages a fleet worldwide of around 1.2 million elevators. Before they were using Azure IoT, they were simply servicing them. Like they would send a technician, they would show up, they would check everything, and go back home. And if the elevator broke in the interim, then they would come back out and fix it. So the very first cycle through this loop was to connect the elevators and know whether they were operational. And for ThyssenKrupp Elevators, that was pretty transformational, right? Because now they knew proactively. Turns out, funny story, a lot of elevators break on the weekends. And so Monday morning, they'd have grumpy customers, and they'd have to go out and fix things reactively. So now they were able to do it proactively. Once they were connected to elevators, then they were able to collect telemetry, use machine learning, predict the maintenance needs, figure out the optimal servicing window. That meant they were servicing elevators 50% less than they were before, but providing a better outcome for customers. So that was their next journey through the digital feedback loop. The next part of it that they figured out was, hey, now that I know when an elevator is going to break down, I can also know, it turns out with a 95% accuracy, which parts to bring when I go to fix it. Like that's significant because now that starts to have an impact not just on how quickly they can service an elevator, but on the supply chain, because it means that they don't have to stock a bunch of redundant parts in all parts of the world. They know where to send them. So that was the next journey through. Then the next thing that they did is they started using HoloLens. They started equipping their technicians with HoloLens. And that enabled them to do two things. One is to see through the elevators and see which parts needed fixing and to actually see the procedures of a fix for them, but also to be able to use Skype Assist on them so that if a technician that went out the first time wasn't able to fix it, they were able to remotely call for help, and a technician in another location could see through that person's eyes and help them fix the elevator. So this is just an example of this digital feedback loop in action. Now, our perspective is that this is a massive opportunity for developers. We're seeing IoT has very much entered the mainstream in terms of a technique. Most customers I talked to 3 years ago wanted to know what it was and how they could benefit. Customers now are going through this digital feedback loop the next time or the next time or the next time. And so it's a very well-established technique. And at this point, we have a pretty sophisticated set of offerings, and we're going to be talking about those all the way through. We're also dramatically increasing our investment. So we are going to be investing $5 billion in IoT over the next 4 years. And that covers a wide variety of areas, from research and development, larger teams building more services, to partner programs, to marketing, to actually infrastructure in the data centers, and on and on. So there's a lot that we're investing in IoT. Azure Sphere, which was recently announced, is a great example of that, right? Now all of a sudden we're revolutionizing a new part of IoT, and we're going to have details about that. Now, what we're seeing is that IoT is touching virtually every market segment. In manufacturing, you're seeing predictive maintenance being broadly applied, increasing efficiencies, being able to introduce new business models. Those new business models mean things like devices as a service. So as an example, ThyssenKrupp Elevators is pivoting to not just offer service contracts, but also to offer uptime guarantees, which, as you can imagine, for a customer, that's what you really want. You don't want a service contract, you want an uptime guarantee. Retail, better customer experiences, better new market opportunities for people. Healthcare, there's a lot of remote patient monitoring that's happening in healthcare. Better outcomes. Transportation, people moving more safely, goods getting there on time, more predictable. Energy, and this is, by the way, one of my favorite parts of IoT, is the environmental impact that it has. It's being used very much for good in being able to reduce the natural resource consumption of our planet, and being able to reduce the environmental impact of industries. And a big way is reducing energy consumption. We're seeing a lot of IoT in smart agriculture, reducing the amount of things that are being applied, like, for example, water or pesticides, yet being able to have increased crop yields. Smarter cities, and on and on. Now, customers are already benefiting from that. We have a lot of great use cases. ThyssenKrupp Elevator, excuse me, I talked about earlier, was already up here. A bunch of great new ones. For example, Bueller, which has a system that is now doing precise grain sorting that's using AI on the edge, right in IoT Edge, to actually sort grains and produce better outcomes. Kohler, building smart, connected, in-house experiences. Hershey's, of course, being able to optimize both their Twizzlers and chocolate lines using predictive maintenance. There's a bunch of great ones here. But to get through this quickly, we see that IoT solutions, there's actually kind of a simple view that we have of these IoT solutions. And this pattern happens again and again and again in IoT. And that's really 3 different parts of it. One is things, which is typically when you're monitoring things. Those elevators, you're monitoring the Hershey's production lines, and on and on. Devices, in this case, are typically a means to an end. Devices are what's used to sense things in the real world in real time. Now, there's insights that you gain from doing that, or otherwise, why would you do it? And then there's actions that you drive as a result. So this is a very simple view. Now, a more realistic view is that there's a whole bunch of other things to worry about. Everything from disaster recovery to updating devices to performing actions on the edge. And this is really where what we're doing comes in. Now, we have a very comprehensive set of IoT offerings at this point across a number of things. Number one, platform services, device support, edge support. We're going to be talking about many of these today. Solution accelerators, and I'm going to give a little more color to this in just a second, and then also SaaS offerings. Now, if you look down at the bottom in terms of platform services and device support, there's a tremendous amount that we have at this point in IoT. Everything from device support with Azure Sphere, Windows 10 IoTK, our open source device SDKs, our certified programs. We have a ton now in edge support. I'm going to explain exactly what edge means if you don't understand that. A bunch of IoT services, a bunch of data and analytics services, visualization and integration services. And this really speaks to our next journey in this phase, which is these accelerators. Because if you are a typical customer, what you see on the screen are awesome, but they're just a bunch of Legos to you. And what you really want is a solution that solves some business problem. Like, I want to know when my elevators need maintenance, right? Like, all of these are great services, but I'm not actually super interested in all of them. I just want to know when my elevators need maintenance. And for that, we've been building solution accelerators. Now, what solution accelerators are canonical IoT patterns, like remotely monitoring devices, predicting their maintenance needs, connecting factories, And these use all of the different services that you see in that box below, except we provision all of those for you right into your Azure subscription. You don't have to worry about how they go together, whether you're doing it right, whether you're following the reference architecture. We simply provision those. And then the next thing that we've been working on is a set of SaaS offerings for IoT. So Microsoft Connected Field Service is what's being used for as you find defects in products and you need to go service them. It's a very helpful SaaS offering for helping you deliver or have technicians go visit those. It does route optimizations, and it integrates with the Dynamics family of offerings. And our newest one that we just announced late last year is Azure IoT Central. And we're going to be demoing that today. Azure IoT Central is a SaaS offering for IoT, where all of the different things that you need, all the different services in the box that you see at the bottom are automatically provisioned into it. We take care of the entire application. You can simply add devices. We will scale the application. We wear the pager. We keep the whole thing running. And you can take it. It's a horizontal offering. You can take it and turn it into anything you want. Like turn it into vaccine tracking or fleet management or predictive maintenance for whatever you want. But the bigger point of showing you that last slide is that at this point we have so many sophisticated offerings that this really calls for an approach where we simplify IoT and make it very, very easy to benefit quickly from. And that includes everyone from enterprise users to developers. And so we're going to be talking about that now. And I'm going to be talking about the ways that we're doing that across making it easy to build scalable, secure IoT solutions from device to cloud, to provision devices at scale. This is another problem. Like customers realize this after they get a solution set up, and then they go to provision tens or hundreds or thousands or hundreds of thousands of devices, that provisioning can be a bottleneck. And so we've solved that with a service. Easier to secure devices at scale, to manage them. If you're driving around trucks to service IoT devices, you're not having a very scalable IoT experience, right? You're fundamentally rate limited by physics versus being able to remotely manage all of those from a central location. Find insights from devices, and then to be able to infuse data with infuse devices with cloud intelligence. And that's what we call edge computing. Okay, so let's talk about, first click stop in our journey is our solution accelerators. And we have sort of two families of them. So we have the Azure IoT solution accelerators. And for those that have been on the journey with us for a little while, we used to call this Azure IoT Suite. We call these solution accelerators right now because that's really what they are. They're a way to get started with a custom solution. And the way this works is that you push a button and we provision all of those services, and we provision a default application into your Azure subscription. And from there, it's yours to customize. And so it provisions in about 5 minutes, and away you go. And if you decide, I don't want to use Azure Storage for storing telemetry, instead I want to go use SQL Server or Cosmos DB, then you simply go into the Azure Management Portal and alter the services. Azure IoT Central is a fully managed SaaS offering that in a lot of ways is a closed system with extensibility points because we're managing the system for you. We still have all the same security and privacy guarantees. But what we're finding is, and the reason why we're doing IoT Central is there's a lot of solutions that don't require intense customization, or there's a lot of customers out there that don't have deep technical skills. And we even find that's true with partners as well. That they just want an offering that they can plug devices into and scale it automatically. All right. Now, both of these, the good news is that both of these are built on the exact same Azure services. In particular, IoT Hub, Stream Analytics, Time Series Insights, Azure Machine Learning, Logic Apps, and more. And so they both adhere to the same reference architecture. The difference is, of course, that we're managing Azure IoT Central. You provide the customization. We keep it running. And you are doing all of the customization for the solution accelerators. Now, the way we like to look at these two is that it's a cohesive story where you can start with Azure IoT Central, and then we provide extensibility points along the way. So for example, one of the things that we're adding right now to IoT Central is the ability to exhaust to any storage account that you want so that you can then go and perform machine learning on it. Then we are going to make it possible to have machine learning-based monitoring rules. And there's lots of other integration that we've got. Today we're going to be demoing Microsoft Flow integration so that as you detect a pattern in data coming from an IoT device, you can trigger a Microsoft Flow, and it's a nice extensibility point. Eventually, we're going to provide an migration experience so that if you start with Azure IoT Central and you decide, I really want that as a custom solution, then we'll provide the ability to create a new custom solution, point it in an Azure IoT Central application, and then take control over it yourself. That'll migrate your devices to this new IoT hub. All right, so the solution accelerators look like this. They've got a great UI, and I'm thrilled to announce that they are now, we just did a huge update on these. We just redid our reference architecture, and they're now generally available. Now, the thing to call out is that everything you see on the screen and lots more, this is all open source. So all of the UI that you see here and UI framework is all open source, and it's all up on GitHub. And it's under an MIT license, which means you can do whatever you want with it. You can take it, you can customize it, you can use it yourself. If you decide it meets your needs and you want to use it, keep using it. If you decide that you want to customize it and then go sell it to someone, you can do that too. So it's really an accelerator to get you going quickly. And as I mentioned, the big update that we just did is now generally available. And so you can go check this out today. We also updated our reference architecture. Our old reference architecture was about 2 years old, and it turns out Azure moves pretty fast. And we have delivered a whole bunch of new IoT services. So we just updated our reference architecture to capture those. The other thing that I'm really thrilled to announce is that Azure Maps is now generally available. You might not know, but Azure has a map service. And it is now generally available. It's also integrated into the Azure IoT accelerators, and so it uses that Azure Maps. Now, why are we doing Azure Maps? Well, it turns out that a lot of IoT devices move around, and all of them exist in the world somewhere. And everybody the customers that we've been working with want ways to visualize where they are, where they're going, to be able to set geofences, to get directions to them. And so Azure Maps is sort of a natural companion to an IoT application. And so this is now generally available. And this has been done in partnership with TomTom, who's providing all of the backing services for it. And so the great part about Azure Maps is that just like any other Azure services, you can use your Azure subscriptions to use them, provision them along with all the rest of your Azure services, and away you go. The other thing is Azure IoT Central, which we're going to be showing in a minute. And Azure IoT Central, again, is a SaaS offering for IoT where you simply connect devices and we automatically scale the application. And it provides everything for defining a device template, all of the different measurements that you're going to be collecting from it, the commands that you send out to it, the device state synchronization that you're doing with it, and then making it easy to monitor data coming from it and then drive actions as a result of any rules that trigger. IoT Central is really geared towards 3 users. There's builders, and builders are the ones that would provide the vertical specialization of it. And it's really nice. What you see is what you get environment, where you can simply go into design mode, customize your application, go out of design mode, and now you've got an application. There's administrators that can take those applications. And by the way, those applications can be packaged up as templates. And then administrators provision those templates. So you can, once you have a template, you can simply create it as many times as you want, add users to it, manage permissions, and then there's operators. And operators are the ones that are monitoring for something. For example, if you produce an Azure IoT application that's tracking vaccines from when they're produced to when they get to a hospital and making sure that the temperature is right the whole way, an operator is typically the person that is monitoring that and looking for violations of that. So that's really the 3 personas that those are geared towards. With that, we're going to start talking about Azure IoT Sphere.
Thank you.
Great.
All right. So let's talk about the world's most populous category of computing. That category are devices controlled by microcontrol units, MCUs. There are approximately 9 billion new MCU-powered devices deployed every single year. They're in toys, they're in home appliances, there are many, many other everyday appliances, or everyday devices. And these MCUs, one way to think about MCUs is they control the world. Almost every fan, blower, heater, pump, motor, anything that happens in the world is connected to an MCU. The great challenge, security challenge of our day is how to bring those MCU-controlled devices to the internet and do it securely. Now, creating highly secured devices is something that Microsoft has a significant experience with. In my 20-plus year career at Microsoft, I've spent almost my entire career figuring out how to address what we call the internet security battle. The battle that comes to your device when you connect your device to the internet. These MCU devices are very poorly prepared for connectivity, and they're very poorly prepared for the challenges that come when they are connected to the internet, particularly the security challenges. One of the things we've published, and we published almost a year ago, is a paper we call the 7 properties of highly secure devices. They're here. A hardware root of trust, a fundamental ability in the hardware to be able to establish an identity of a device and to protect the integrity of that device from a hardware level. Defense in depth, multiple layers of defense, so that even if an attacker manages to find an exploit in one area of your security, that you're able to overcome and mitigate that attack and bring the device back to a secured state. A small trusted computing base, where the most safety critical aspects of the device are protected and in inner areas of the code, and then other higher level functions are separated so that, for example, connectivity, so that errors can't propagate down into the lower device. Dynamic compartmentalization, the ability to create multiple firewalls within the software of a device to protect that device. Certificate-based authentication, permanently doing away with passwords on devices. Failure reporting, the ability to be able to monitor these devices globally and understand how they are being attacked and how to counteract that. And then, most importantly, renewable security, the ability to upgrade and improve the security on a device in deployment over time. Now, you may look at this list and say, that is an impossibly hard job to do, to create a device that has all 7 of these properties, especially on something as small as an MCU, a single chip computer. With Azure Sphere, we have created an end-to-end solution that allows any manufacturer creating MCU-based devices to create a device that has all 7 properties of a highly secured device. Our solution has 3 components. The first are an entirely new class of microcontroller. These are microcontrollers that incorporate Microsoft secure silicon technology that we have developed based on our learnings from 15 years of securing the Xbox consoles. On top of that, we have a new operating system, the Azure Sphere operating system. This is a security operating system that combines the best of our learnings about how to secure Windows with open source technologies. We've actually used a custom Linux kernel as one element of that defense in-depth operating system. And that allows us to stretch globally across the entire MCU silicon ecosystem. And the third component of Azure Sphere is the Azure Sphere Security Service. This is a security service that runs in our Azure Sphere data centers and reaches out and touches and protects and guards every Azure Sphere-based device. It does 3 critical things for those devices. First of all, it brokers trust through certificate-based authentication so that these devices never have to have passwords. The second thing it does is it detects emerging security threats across the entire ecosystem of Azure Sphere-based devices so that we understand new security threats as they emerge and so that we're able to mitigate them. And the third thing it does is it renews device security by providing full software update, both of the operating system and the other components of the security system, and of the applications, the firmware that runs on those devices as well. Now, in addition to bringing truly best-in-class revolutionary security to these MCU devices, we've also brought the power of the Visual Studio development environment, the IDE, and the ecosystem to MCU-based devices for the very first time. Now, for those of you in the audience who may have programmed an MCU before, you'll know, as I do, that MCU development experiences are still very firmly grounded in the tool technologies of the 1970s. you can get rid of your disco pants and join the modern age, even programming these devices at the very, very edge. Rush me. Let's talk about what we can do with Windows now.
All right. Thank you, sir. Thank you, Galen. So as we fill out this placemat of different technologies that Microsoft has for IoT, let's talk a bit about Windows 10 IoT. So, Azure Sphere, as Galen pointed out, is an awesome solution for these MCU-class devices that bring this higher security and capability than ever before. But what if your solution requires a more powerful compute device? What if you need something that has the power and capability of a microprocessor computer? For that, we have Windows 10 IoT. And we talk about these three main values for Windows 10 IoT. The first is time to market. When you're creating your device and bringing it to market, you should be spending the most of your time focused on your unique value that is what your device represents. If you start with a more complete operating system like Windows, you've got all of the underpinnings of Windows there for you, which means all of the bring up of the operating system, running it on the hardware, worrying about compatibility with different graphics and this and that, making sure that Wi-Fi works, it's all there for you. And as a result, you get to just rely on the fact that the platform is running on a complete OS, and you get to just write the application on top. It allows you, again, to focus your time in the right spot. So it's about faster time to market. And then, of course, because we're talking about Windows here, we've got all the intelligent security that exists in Windows today built in for you for your IoT devices. If you think about it, Windows is battle-tested every day around the world in hundreds of millions of devices. And we've done a lot of work to secure those devices, to secure that operating system from design through design, through reaction, through patching. We've got a lot of effort going into security. All of that is an effort that you get to take advantage of as well by using Windows to build your devices. And then finally, that combination really makes Windows the best operating system available for you to produce your intelligent edge device in this class of devices. So that's a bit about kind of how we talk about it. As a quick review, we've got these two editions of Windows 10 IoT I want to talk about here. The first is Windows 10 IoT Core. Think of this as taking Windows and we shrank it down. We removed out a bunch of stuff from the desktop operating system to bring it down to its core, such that you can now run on a class of these more constrained IoT devices. Think of them as sitting kind of above the spectrum from Azure Sphere, but below the spectrum from a desktop device. And so here we're talking about things that are like Raspberry Pi. They're running ARM32. They've got less than a gig of RAM. That's kind of the space we're talking about here. And as a result, of course, we've got a smaller footprint on the device, which means but you've still got the full UWP surface area there for you for your applications. And then if we step up from there, we have Windows 10 IoT Enterprise. Now, this is exactly the same. It is identical to Windows 10 Enterprise that many of you are familiar with today. The only difference here is that we actually just make it available in a different way through different licensing and distribution such that Windows can ship with the device. It's got all the traditional Windows shell that you're used to. It has all the advanced lockdown features that enable you to take a PC-class device but turn it into your appliance. So when we think about Windows as the underpinning OS for your device, it's really important to think about when you embark upon an IoT journey for your device, not only how are you going to prototype something to see if it's going to work, but how are you going to do that at scale for a commercial IoT device to get to production? So I think of it sort of in this way. I think you'll all probably remember Maslow's hierarchy of needs from school. This probably sums up my sum total of understanding of human psychology right here on this slide. But we know from his model that the most basic needs at the bottom of the pyramid must be satisfied in order to build up from there. And I like to apply a similar model to commercial IoT devices. And so here again, I'm talking about making these real production-ready commercial IoT devices. And at the base, you need to start with hardware and OS platform that will be available and supported for you over the long haul. Whatever operating system you choose for your device, you need to make sure that that's there to give you long-term support with security updates throughout the life cycle of your device. And crucially, if your operating system doesn't provide that for you, that means you are on the hook for doing it yourself. Above that, then, you can now think about you'll have a need to distribute and manage security updates as well as manage the devices themselves while they're actually out there in the wild. This is sort of key to operationalizing your solution. Once your devices are out there, you need to be able to take care of them. In a connected world, the days of building an embedded device that you just ship it and release it and then you forget about it, those days are gone. Because as Galen mentioned, in a world where these devices are now connected to the internet, you've got to stay current on security. You've got to be able to renew the security on that device in order to keep your customers safe. Next, we can think about, now that we've got these layers in place beneath you, you can think about how do you start to build your own device-specific functionality. And this will vary widely depending on what kind of device you're building and what kind of IoT solution you're going after. And so critically, what does your operating system provide you with in order to do this as you build your device functionality? It's going to vary a lot, as I mentioned, but for example, do you need a graphical interface? Do you need touch? Do you need ink? How about a speech recognition? Or how about beamforming across a mic array? Or doing, having audio graph APIs that will let you mix audio from different sources? Or maybe you're doing video transcoding or face reco and tracking. Like there's a whole bunch of different things you could be doing with your device. And you could start with a bare bones OS and try to pull together solutions for each of these different functionalities that your device might need. But keep in mind the layers below this one of the pyramid. Once again, the more you pull together yourself, the more you're on the hook for servicing. You now have to be responsible for sourcing, testing, distributing any security fixes for anything that you pull into your solution. And so it's to your advantage to choose an operating system that includes all this stuff for you, because that way it'll get serviced just as part of the OS itself. So now we can start getting to some more of like thinking about how do you do cloud offload. Now we can manage things like data gravity and make sure you're doing compute in the right place. You can use Azure IoT Edge to make sure that compute is happening in the right place. And ultimately, this helps you build to the top of the pyramid, which allows you to start thinking about edge intelligence. And this is really the ability to leverage these intelligent microservices between the cloud and the device such that you can run right where the data lives. And of course, remember, your ability to do this is predicated on all the layers below this in the pyramid. Finally, depending on your industry and depending on any regulation that might apply to that industry, you may need to get your solution certified from end to end. And if you build on a platform that has gone through the appropriate certifications, that'll make that process all the more easy for you. So let me use this model now to talk about what's coming in Windows 10 IoT over the coming year. And much of this is going to be focused on our upcoming fall release. First and foremost, earlier this year, we were really pleased to announce support for NXP's IMX6 and IMX7 SoC families running on IoT Core. NXP brings industrial-grade, long-life silicon to Windows, and we're thrilled to be working with them on this. We're in private preview on this right now. Public preview will be happening later on this summer, so we're very excited to have this coming out because it opens up many more new opportunities for all of you as our developers and device builders. Also, we've also announced earlier this year, coming in our fall release, IoT Core will have 10-year support via our long-term servicing channel. This matches now what we had with IoT Enterprise as well, which also continues to have that support. What this means is, by talking about the long-term servicing channel, over the course of these 10 years, you get to keep current on security updates while minimizing change because you're not picking up any feature updates or new functionality that might be pushed as part of new updates, new release of the OS. Instead, you stay on your existing release of the OS, whatever you've chosen to put on your device, and you just get security updates that will keep you current. And ultimately, that helps you minimize your operational risk for your devices that are out there. Next up, we also, in the kind of the next rung now, we talk about device management. We're continuing to improve our existing Azure DM samples that we've had on Windows for many releases now. And we're making them even easier for you to include them into your Windows 10 IoT solution. And then on top of that, we're very excited to be releasing the Device Update Center for Windows 10 IoT Core in our next release as well. Let me talk a bit more about what this means. So we spoke about Device Update Center. Our first time we spoke about it was actually at Build this time last year. And at that time it was a concept. But now it's real. Now we have it in private preview, coming in public preview in a number of months later this summer. And first and foremost, what this gives you is device makers will get full control over updates to their device. This means nothing will land on your device before you get a chance to test it. You are in full control of that. Second, you get to compose your device updates with any combination of what you need. We make available to you the operating system security updates, and you can choose to pick those, your own drivers, apps, files, any other secret sauce that you've got on your device that you need to be able to update. All of that is stuff that you can choose to take either all at once or however you like a la carte to be able to put those things down on your device. And then when you're planning an update for your device, it's very important to do that carefully and planfully. You want to make sure everything's going to work as you expect. And so we're giving you the ability to manage your rollouts of these updates through rings of devices, very similar to how we do flighting for the Windows Insider program. We now give you that opportunity to define your own rings and be able to manage your own updates going out to those rings such that you can start with a small group, collect telemetry and feedback, make sure everything's okay, and then go to a broader audience. Now, to be able to do that, of course, you need infrastructure. You need an infrastructure that will let you scale to however many thousands or millions of devices that you need to be able to scale to. And so what we've done is we've built this on top of Windows Update, a global scale, massive infrastructure that now is in your hands. This is the same infrastructure that we use to update hundreds of millions of Windows devices on a regular basis that now you get to deploy and use, you get to employ for your devices. Tomorrow afternoon at 1:15, there's a session given by two of my coworkers, James Colas and Chirag Shah, where you actually see this live in a demo. So, with that, back to our pyramid for the cherry on top of the sundae, where we can discuss now an intelligent end-to-end intelligent edge to intelligent cloud platform with both Azure and Windows. And so what we're doing in our upcoming fall release is we're stringing together a bunch of great technology that will really help empower all of you to create intelligent edge devices that use the power of machine learning and artificial intelligence running right on the device. So first up, we've got Azure ML, which many of you are familiar with today. It's for being able to use existing models, create your own machine learning models, and to train and retrain those things in the cloud. We use Azure IoT Edge for orchestrating inferencing of those models between the cloud and the device. And when they run on the device, they'll run on top of the Windows AI platform using Windows ML. Now, Windows ML, as we've announced earlier, will give you the ability to accelerate your evaluation of machine learning on any DirectX 12 compute hardware, which means a broad array of GPUs. In the future, it'll include MPUs and VPUs as well, to be able to accelerate that workload. And then finally, this will be available to you across Windows 10 IoT Core, Enterprise, or Server, depending on the size of your device. And once again, you'll be able to see a demo in that same session that James will give that applies this whole stack using real hardware, computer vision, to be able to detect defects during steel manufacturing that we're doing with a customer of ours. So to pull it all together, when you take a step back, you can really see when you start with a solution like Windows 10 IoT, you've got your secure and manageable IoT OS with long-term support. We give you Windows Update and the Device Update Center to give you control over how you update those devices throughout their life cycle. We then talk about device management. Windows 10 has a ton of manageability features within it, and we've plumbed all of that through for you into Azure. And then finally, we've done this combination of machine learning, Azure IoT Edge, Windows AI, and Windows ML to be able to bring accelerated AI to your device. Okay, I think it's demo time. Guys, you want to come back and join me?
All right, so let's switch over to this guy, which is probably falling asleep. All right, so we thought we'd do a quick demo to show a couple things. The first that I wanted to show is how easy it is to quickly provision an IoT Central app. And by the way, the buttons that you're going to, there's going to be some buttons given away. So you'll be able to use those with IoT Central as well. So let's go to the IoT Central's app manager, create a new application. One thing that I wanted to call out is that you can create an entirely free one that's free for 7 days. It requires no Azure subscription at all. You can just go and use it, connect devices to it, play around with it, see what you think. You can extend that if you give us an Azure subscription. You can extend that to a free 30-day trial. And then after that, you can either start paying for it or delete it. entirely up to you. So I'll pick a free one, and we've got a bunch of great dev kits. I'm going to go ahead and pick the default name, and I'll click create, and it's going to go and provision this. And just like that, I have an IoT application. There's a bunch of different parts of this, like a device explorer. Here's 3 of our developer kits, the MX chip, the Raspberry Pi, and also one for Windows 10 IoT Core. If I go into the MX chip, you'll notice I can see all the different telemetry that it's collecting. This is, by the way, out of the box. Any device properties that I want to synchronize with it, some read-only properties that might be coming back from it, any monitoring rules. For example, there's a rule that we set up to detect a certain condition, like a temperature greater than 60. And then each dashboard or each device has its own dashboard. If I go into design mode, which is that builder mode that I was telling you about, this is all completely configurable. If I decide I want to drag this around and put it in a different place or get rid of it or expand it, it's super easy to do. And when I'm done, I pop out of design mode and I'm back to the application. And then when you're done with an application and customizing it, you just save it as a template, and then you can provision that as many times as you want. So it's a super easy way to get going. And we thought it would be fun to put together one that uses both Windows as well as IoT. And for that, what we did is we built this little application. And again, I can always go into design mode and move things around. We built a little application that uses both Azure Sphere as well as a Windows 10 IoT Core device. Now, the Azure Sphere device, Galen, do you want to tell us a little bit about this one?
Got this? Mm-hmm. Okay, so we built this using an Azure Sphere development kit. These kits will be available in September, by the way. If you want to reserve one and get in line, you can go to our website and place an order to pre-reserve them. Right here is the very first Azure Sphere production chip, the MT3620. And then we have a board that brings out the Wi-Fi antennas and gives some access points. And then we've combined it over here with a 28 by 14 pixel flip dot display. And just a simple serial connection between the display and to the board.
All right, so if I go back to IoT Central and I go into settings, if I were to set a timer, somebody give me a number between 15 and 10. 12, okay, I heard 12. Okay, I'm going to say 12, and then maybe we'll do invaders. So I'm going to hit update, and what that's going to do is it's going to make this. So I just issued a device management command to it, synchronized some state with it. The code running on the Sphere device is now doing a timer and counting down. And the end of it, it's going to, someone got a little carried away in our team and built a little Space Invaders thing. It does Pac-Man now too, so it's
all highly secured.
All highly secure. The tiny little MCU that's the size of your thumbnail. But that's how easy it is to manage a device in IoT Central. It takes just a second to connect a device. You give it a connection string, connect to it with VS Code, or deploy an application, and away you go. We'll have talks that'll show just how easy that is. The other thing that we're doing as part of that is we're automatically detecting a rule. In this case, what we're doing is we're raising an event when the device completes that countdown, and that in turn goes and triggers a Microsoft flow to insert a new entry into a Microsoft Teams event. All right, so if I go over to the Windows 10 IoT one, see this one back here, and Rashmi, do you want to tell us a little bit about this one?
Yeah, sure. So here what we've got on the back here, maybe you can flip to the camera.
Oh, he's got the camera right here.
On the back, if you can get this device here, this is this device right here is running Windows 10 IoT Core on a Qualcomm 410E system on a chip. And it's by a company called Raycom. And what we've got is up here a little smart display that we have. And you can see here that it's got, of course, touch, multi-touch, and if you can flip to the display there. And it's just a very, very simple universal app that we've built up there.
Okay, so we're going to manage this one. And for this management, what we're doing is we're going to go into settings, and we're going to change which location it's in. So right now it was just in Redmond. I'm going to set it to Seattle. And actually, can we get a shot of it?
We can flip to this.
All right. So I just entered Seattle, and I'm going to go ahead and hit update. And it received a device management operation, and it changes its display to Seattle. So anyway, that's very, very quickly, that's how easy it is to provision an IoT central application. It takes just about 15 seconds. When we put this together, it takes about 2 minutes to customize each device and then respond to those commands that are coming down. We're going to talk about them in our next section, what was happening as that device management operation happened. But anyway, so that's connected to the world's most secure MCU class device, as well as the world's most secure, fully capable IoT endpoint. All right, so let's go back to our talk. Great. So I'm going to talk quickly about some of our key services in IoT that these devices were just being managed by. The first is Azure IoT Hub, and the second is our device provisioning service. So Azure IoT Hub, and we're going to have deep dives on this all week. Azure IoT Hub does everything from bidirectional communication over today's popular IoT protocols, MQTT, AMQP, as well as HTTP. Does enterprise scale integration so that I can connect to, as data flows through the IoT Hub from millions of devices, sending trillions of messages, that I can route those to downstream Azure services, that I can put them in storage systems, perform analytics on them, and on and on. And then we also provide end-to-end security with everything from per device X509 certificates, IP whitelisting, blacklisting, only supporting TLS protocols. You can use this to keep your devices secure. For example, as we were just managing these devices, I can use those same device management primitives to update the software and confirm firmware as I do the applications themselves. Now, I wanted to take just a quick moment and talk about how device management works and how it worked when we did the demo here. The way it works is that for every device that you're running our SDK on, we also have REST APIs so that you don't need to use our SDKs to take advantage of this functionality. They just make it easier. We have the concept of a device twin. And what a device twin is, it's a state synchronization primitive that we use for managing devices and synchronizing the state, even when devices become disconnected. And then when they reconnect, we resynchronize. The way device twins work is that there's a number of JSON-based name value pair property collections, and you can use them however you want, and I'll explain. So there's a desired property. Desired property collection you use as a way from the cloud of saying, device X, I would like you to go to this state. So for example, when we were managing this one, what we did is you saw 2 different properties. We set a timer interval, and we also set a message that we wanted it to do at the end of the interval. Those were both desired properties that we set. What we did is we set this device running on the Azure Sphere chip, it received, running the SDK, it received a notification that 2 new device desired properties had been set. And what it did is it simply responded to those and triggered the animation that you saw here. Then it wrote back to reported properties, which then flowed back to the cloud through IoT Hub. And now I have attestation between the two. So I can see equilibrium. I can see how many of my devices did I command to do something that have now done that. And so you can use this to manage software and firmware, as well as parts of the application. There's also tags and methods. Now, what tags are for is a way of grouping these. And so, for example, I can have a tag that says, this device is in this conference room. And then later, if I want to search for those, it's super easy to just issue a query across millions or billions of devices, find those, and then perform an operation. And in addition to queries, we have the ability to do jobs. And what a job is it's a long-running process that operates over millions, potentially, of devices and performs device management operations. Now, I'm really excited to announce this week that we're previewing a brand new feature in Azure IoT Hub called Automatic Device Management. And the way this works is pretty cool. The way this works is in that last example that I was giving where you would query for a set of device twins, find them, create a job, and then execute that job. If one of those device management operations failed, let's say something was happening with the device, then I would get notified of that. And then the general process I would take in my solution is, go find out what was happening in the device, create another job, and then run that. Instead, we thought, since that was such a frequent operation, we saw customers doing that, we thought we should really build IoT Hub as a goal-seeking engine for device management. And so we still have our existing job infrastructure as well as device twins. We also added a new capability called automatic device management. Now the way that that works, let me walk through a scenario. Let's imagine that I had a set of smart meters in Redmond, for example, which is just over the bridge here, and in Seattle. And I decided for Seattle that for 4th of July, there's a big fireworks display down in Seattle, and I want to raise the prices. I want to move them from $1 an hour to $2 an hour. The way I can do that now is I can simply go into the Azure IoT Hub management portal, and I can create a standing query. Select star from devices where tags.location equals Seattle. And tags is that name value pair that exists in the cloud that I can use for any arbitrary grouping of devices. And then I can do a set desired hourly rate equals $2 or 2. What'll happen as soon as you set that up, we will immediately query any devices that are attached for those tags on their device twins. And if so, we'll blast out an update and goal seek against them. And continue working until all of those desired properties are equal to those reported properties. And that operation has completed. The other thing we do is that if new devices come online, let's say you just added a new set of devices and they had that same device twin property, tags equals Seattle, we would immediately recognize that. Now that might have happened an hour later, a day later, a year later, it doesn't matter. Once you set up the standing query, we will goal seek to it. So that's automatic device management. And it works against both device twins, and we've also enabled it for IoT edge deployments. So for example, if all of those smart meters were running IoT edge, and I'm going to tell you all about that in just a second, and you detected that, and we detected that you'd added new ones that matched that, we would then deploy an IoT edge deployment out to it. All right, so that's automatic device management. The IoT Hub device provisioning service, this is our service for solving the challenge of provisioning devices at scale. Now imagine that, what I just showed, the smart meters. Device management right now is very manual, and so I might have a solution in the US, I might have a solution in Redmond and in Seattle, I might have a solution in Germany, I might have a solution in China. New Zealand, don't want to, close enough, yeah. Yeah, I should add a New Zealand. I'll add in Australia too. We have data centers everywhere. So if I have these individual solutions in different parts of the world, and I go about provisioning devices to them. And if you think about the challenge of provisioning 10,000 or 100,000 or 1 million devices over a short amount of time, it's very error prone. Like if you're attaching little jumpers to it or going over Wi-Fi, it's very error prone. What you want to do is you want to centralize your logic. So the way we do that is we have this second service called IoT Hub Device Provisioning Service. And it has a global endpoint that any device on the planet can contact. So it's a single one that we DDoS protect and geo-replicate and all that. And the way that you can do it is you can go in and pre-register devices with it. Now, these devices might have been manufactured 2 years ago, and they have some SDK for the device provisioning service on them, pointing towards that global URI. And then 2 years later, you decide, okay, this one's going to China, this one's going to the US, this one's going to New Zealand. And so when the device wakes up then and contacts that service, it will say, hey, I'm here to be registered. Which IoT hub do I belong to? And the device provisioning service will turn around based on the information that you told it and go and register it on demand with an IoT hub. Now you can do this statically or you can do it dynamically with an Azure function. You can also do geo-sharding, so you can say if a device wakes up in this region, it goes to this one. The device provisioning service registers the device with the IoT hub. It then passes the device credential information and tells it what to present when it attaches to the IoT hub, when it goes and connects to it. And then the device simply disconnects from IoT Hub device provisioning service, reconnects to the right IoT Hub, which it's now been registered with. And then because we now have event support, you get notified in your solution that there's a new device that's connected, and you can trigger that device management workflow that same one. So for example, this one, if we went through device provisioning service and connected it, and it had a tag that matched the one we were looking for, then we would simply do automatic device management and go and configure it. So that's how that works together. All right, IoT Edge. IoT Edge is something that hopefully you got a chance to see in the keynote this morning. There was 2 IoT Edge demos, one with DJI drones and Qualcomm cameras, The other one, which was a Scott or not Scott scenario that we did with custom vision service running on a device. So the IoT pattern that we've been talking about so far, where you see sort of a lot of the same use cases happening again and again, predictive maintenance and things like that. IoT Edge adds a whole set of new use cases. In particular, there's a bunch of them with AI on the edge, and I'll talk about that in just a second. So the traditional pattern where I'm sending data from a device to the cloud, storing it there, performing analytics on it, driving actions based on the insights that I find, and then sometimes issuing a command back out to the device. That keeps happening, except with edge computing, I can now take things that run in Azure, such as Azure Machine Learning, Azure Stream Analytics, Azure Functions, Azure Cognitive Services, Azure SQL, and I can push those out in a Docker container and deploy those out to a device. And they run right on the device themselves. And they can run in closed little loops right on the device. And then typically what you see here is once you start doing this, let's say I was doing predictive maintenance in the cloud, where I was sending everything to the cloud and determining the maintenance window and then adjusting it and then triggering a sales or a technician to go service that. I can start taking that same logic, that same machine learning that was running in the cloud, or the same stream analytics job, export it from the cloud, run it right on the device, and then the device can start doing something really interesting. What it can start doing is processing its own data. And then it can just start simply sending alerts to the cloud that says, my maintenance window changed. And you can also start uploading data to the cloud at a much lower frequency. So you could start doing something less expensive, like just plain file upload. So that's what edge computing enables. At a high level, the way the topology works is so IoT Hub can connect to any device on the planet. You can also have these specialized edge devices. An IoT Edge device is just something running our middleware, Azure IoT Edge, which is now going to be open sourced as well. And so that middleware enables you to push workloads down to it through IoT Hub onto the device. And it can also work in a gateway configuration. So you can put lots and lots of devices behind the IoT Edge device and manage those locally. Now, the way a IoT Edge deployment works is that we have a set of Azure services and some new ones that are on this slide that are in development, such as Azure Event Grid. You simply produce some functionality in those services, and now there's places in the Azure Management Portal where you can export those into Docker containers, and you place them in an Azure Container Registry. You can then author applications, or what we call deployments, combined of one or more of these containers, all interrelated, that can work together to produce some IoT solution. As an example, if I'm doing AI on the edge, like this morning we showed the DJI drone. If I want to do something like I could have a module or a container that's connected to the video camera itself and is receiving video. And then as it receives video, it's sending it to an AI model running in a second container to score it. That's what we were doing this morning, looking for an anomaly. And if anomaly is detected, the thing that was happening this morning in the drone demo was that when an anomaly was being detected, all we were doing is that container that's running the machine learning model was simply saying, here's the bounding rec that anomaly is at in the video frame. And that's how we were drawing it in the video frame. And then you could either send that to the cloud or you can process that locally. The way you deploy one of these down to an edge device is you go into the Azure IoT Hub Management Portal. We also support this in VS and VS Code. You author what's called a deployment manifest. What the manifest specifies is all of the different containers that you're going to be sending down, how they interrelate, as well as any configuration that you want to apply to them. You send that down to a device, and again, if you can send it to one device, you can send it to millions of devices. And now we can do automatic device management and automatic deployment to all of these devices as well. Once that deployment manifest goes out to the device, it causes the IoT Edge runtime to turn around to that container instance and download them. And then it downloads the containers, it places them, it activates them, and the solution keeps working. We even recycle the containers if they stop working. And we have watch guards and things like that, so if they start using too much memory, we can recycle them. And you can manage each one. So for example, if I want to alter the way a machine learning model is working, I can simply set a property on something called a module twin in the cloud. You'll learn all about that in our Edge talk. I can set a simple property, just a little JSON property in the cloud. It'll go down to the container, raise an event. The container simply responds, updates itself, and reinitializes, and then writes a reported property back to the cloud. And now I can tell, yep, that container has acknowledged the command that I just sent it, and it's reinitialized. All right. We announced 2 new partnerships this morning, one with Qualcomm on a pretty fancy camera that's running Azure IoT Edge, as well as some pretty sophisticated hardware-accelerated AI. Those cameras will be available this summer for preview. We also announced a partnership with DJI. The drone that you see here, the DJI M210 RTK, is actually running Azure IoT Edge on board. And as it flies around, you can push AI models to it. You can even push AI models to it from the cloud to a flying drone. And it will update them. So for example, if you're flying over a particular environment and you want to deploy a different deployment that's better at detecting what the environment looks like right now, you can do that while the drone's flying. It's super cool. You can also, some of the lower powered drones don't have enough compute capability on board. And so what they do is they stream video back to a base station. In the demo this morning, we were showing that base station being a laptop, which of course Azure IoT Edge runs on Windows as well as Mac laptops. Okay, couple announcements actually. We have quite a few announcements. Number 1, we're adding support for cognitive services. You saw that this morning in the Scott Not Scott demo. So that's, I can simply train an image classifier, deploy it down to IoT Edge in a container. Next, we're adding support for Event Grid. This is in development. This will be coming soon. Pretty soon, you'll be able to have Event Grid events working between containers in the cloud or between containers out on the edge or cloud to edge. And so that's all coming soon. We just added support for Kubernetes. I'm going to talk about how this works in just a second, so I'm not going to belabor this. IoT Hub, automatic device management for IoT Hub deployments. We've also added support for VS and VS Code, as well as Visual Studio Team Services for CI/CD support. So now I can do everything from check-in code to it automating a deployment and going and building the code in a container, running tests, deploying that container to a test cluster, and then deploying it to a production cluster in response, all in response to me checking in. So that's pretty cool. We did announce IoT Edge is going to be open sourced, and we didn't announce in the keynote this morning, but the Azure Marketplace now has support for IoT Edge containers. Now, why is that significant? What we're finding is that as you build your solutions, sometimes the pieces of functionality that you'll build in IoT Edge are useful not just to you, but maybe somebody else. And so this is a marketplace where you can put your intellectual property in our marketplace and other people can buy them. Think of it as an app store for the edge. And so we just announced support for that as well. All right, Kubernetes support. So Kubernetes is a big area of focus for ours in the cloud. There's a lot of great production scale cloud applications that are being built that take advantage of Kubernetes. And it has a great management interface for deploying containers, healing them, patching them. So what we've done since IoT Edge is a container-based system, what we've done is we've added support for something called a virtual kubelet. Now, a virtual kubelet is a new concept in Kubernetes, and we worked with the ecosystem to help introduce it. So a Kubernetes cluster has a series of nodes, and what you typically see is that each node contains a set of containers. You can target different containers for different nodes. So there's a new type of node called a virtual kubelet node. And what that means is that there's code that's running in there that will interpret a Kubernetes command and interpret it however it wants. And so typically what that Kubernetes command is just place a container inside a VM. So what we've done is we've introduced a new open source IoT Edge provider that you can run in Azure. And what it knows about is it knows all about IoT Edge, and it knows how to get containers down to it via IoT Hub. So now we've effectively virtually extended Kubernetes clusters so that they can span both the cloud and the edge. And it's not just one device, it's millions of devices you could target. So what that means is as I place a Docker container in that virtual kubelet with the IoT Edge provider, it will, instead of placing it in a VM, it will send it down to an IoT Edge device and then report health back as if it were a VM running in Azure. So now I have a single pane of glass running across Azure and the edge where I can manage and place containers, all using the Kubernetes management interfaces. And I can place as many as I want. Now, why is this useful? One of the reasons why it's useful is that in IoT, there's a typical pattern where you see sort of a do action and an undo action in the cloud, between the edge and the cloud. And so, for example, I can typically what you'll see is I'm connected to some device, I'm pulling data off of it, then I'll compress it, then I'll encrypt it, then I'll send it to the cloud. In the cloud, I typically decrypt it, then decompress it, and then send it along to storage. So being able to have a single Kubernetes cluster where I can deploy these simultaneously to the edge and the cloud is a pretty cool feature. So anyway, that's Kubernetes support for Azure IoT Edge, and that is available now. So how does this all fit together? Yeah, you can clap more if you, yeah. And like I said, that, like IoT Edge, is open source. All right, so how does this all fit together? Well, there's obviously Azure in all of our different regions. They can connect to Azure IoT Edge devices, which are capable of running both Windows and Linux, targeting the same runtime and being able to deploy cloud services out to those. There's also our open source IoT device SDKs. We have 100 or 1,000 different devices that have been certified by 220 partners. It runs on virtually anything at this point. It's multi-language, multi-operating system. We support 5 different programming models or programming languages for it. Again, that is open sourced. And then Azure Sphere with the Azure Sphere devices and Azure Sphere OS. So this is sort of how all of these relate. And so specifically, you can have Sphere devices connect directly to Azure. Any device on the planet connect directly to Azure. You can also have devices connect via gateway, via Azure IoT Edge in a gateway configuration, or Sphere ones connecting to it. Now, one of the fun announcements that we just made recently at Hannover Messe in Germany was that Azure IoT Hub is coming to Azure Stack. So for those that aren't familiar, Azure Stack is Azure itself being able to run in an appliance on premises anywhere in the world. You can put them on cruise ships or submarines or wherever you want. And you can take the same Azure deployment and turn it around and deploy it down to an Azure Stack device. Now, Azure Stack is going to have Azure IoT Hub. We're building that in there. And that's significant because it means now I can start to have an Azure Stack deployment with Azure IoT Edge devices or Sphere OS devices or Sphere devices all running in isolation on the edge and have that same management experience that I have in the cloud. For example, I'll be able to run that Kubernetes cluster, but it'll be able to run entirely on-prem in Azure Stack, spanning Azure Stack as well as Azure IoT Edge. So there's some nice symmetry to what we're building here. And it's quite intentional what we're doing. Anyway, this is how all of it relates. The last thing to talk about, and then we're going to hopefully have a few minutes for questions, is time series insights. Now, many IoT devices send time series data. For example, as you're measuring temperature or humidity or vibration, that's typically done at some interval, right? And then you start sending all of that. And let's say, for example, that I have a device, a composite device like a generator, where I'm managing different things. I might be managing temperature every second, and power draw every second, and vibration every second. When you start, one of the things you find in IoT is that you often need to correlate across different time series streams in order to do root cause analysis. As an example, excessive vibration might have been caused by higher power draw, which might have been caused by increased temperature. But to find those correlations can be like finding a needle in a haystack. Now, it looks simple on this slide, but when you start to think about millions of these sending billions of messages over years, and if you're managing all that and you're just dumping it into Azure storage, that can get out of hand pretty quick, right? And if you want to go find that needle in a haystack, then you're typically applying traditional data wrangling techniques like MapReduce to find those. Right now, we estimate that by 2020, the world will be generating 4 zettabytes of time series data every year. That is a lot. A zettabyte is 1,000 exabytes, which is 1,000 petabytes. So it's a big number. Yeah, it's a lot. Yeah, it's not something for the faint of heart. And so you really need a service that can scale massively and help operators find those insights quickly. especially across different devices. Now, you might imagine that generator might be simple, but in a manufacturing plant where you've got thousands of devices all sending data that might be interrelated, finding those insights is very tough. It's very tough to do, especially if you can't see it visually. So Azure Time Series Insights is that service that we've built that is generally available to find these needles in the haystack in by far the most frequent type of IoT data, time series data. So the way that it works is it's an at-scale time series data store. This is a massive store that Azure uses, and we had it for years. What we were using it for originally was to store all of the log analytics for Azure services worldwide. So we're writing like exabytes to it. It's a massive scale store. It's a schemaless store, which is super cool. What that means is that you can just start sending data to it. So I can provision time series insights. I can point it at my IoT hub, which just takes a few seconds. And then anytime I send data to IoT hub, that'll automatically be routed to time series insights. And when you open up the time series insights explorer, so it's not just a scale, it's also a user experience that we provide on top of it that enables you to do ad hoc queries, to create charts, to find visual defects, to be able to stack up different time series things, to be able to zoom in, zoom out, see the actual data, and more. What happens is because it's schemaless, we just automatically start indexing the most frequently used fields that you're looking for. And then later on, as the schema drifts, like if the device is no longer sending that, then we do schema pruning as well. So you don't have to go and create a big schema map in order to tell us what types of data is coming in. Makes it very, very fast to use. So there's going to be some talks this week that'll show time series insights as well. You can take data sets of tens of millions or hundreds of millions, query across it, and it takes just a few seconds. Now that would typically take an hour or so in some batch analytic job. It takes seconds now, and it also includes a UI experience. The other thing I should point out about that is that Azure Time Series Insight is actually integrated now into IoT Central. And so all of the data visualizations that you see in IoT Central are being powered by Time Series Insights. So the data store that's being used in IoT Central is that. We also provide a rich set of JavaScript libraries so that you can embed time series insights into any arbitrary web application of yours in just minutes. And then we have a whole bunch of new features coming. Number one, a tag-based user experience. And to borrow the parlance of time series stores, tag-based is basically if I want to say, hey, these three things are a generator, I'm able to do that, right? And then later on I can say, I'd like to find all the generators that are in this part of the world. And then I can quickly filter those and then see their time series data. We're doing business report integration with Power BI integration, so you can host time series insights charts in Power BI. We're doing predictive analytics, or enabling predictive analytics by integrating with Azure Machine Learning. So you can run Azure Machine Learning right over time series insights. We're also doing data analytics with Jupyter Notebooks as well as Apache Zemlin integration. And then finally supporting Azure Databricks, Hadoop, as well as Spark integration with time series insights. So that was a whirlwind tour of everything that we do for IoT. There's a lot. And by the way, I glossed over a lot. So this is one of the reasons why we're simplifying IoT. Make it easy to get started quickly and to do everything you need. Okay, there's a bunch of great talks this week. There's also 2 new resources. This is something we just started about 4 months ago, the IoT show. So we have a new episode every week. We talk about IoT topics. You can come and hear all the cool things people are doing and all the new innovations. And we just launched the IoT School. And what IoT School is it's something for you as developers to go and learn all of the different things that we talked about today, that we're talking about the rest of this week. It's a little self-guided tour. It's completely free. You can go at your own pace and increase your skill set in IoT and get started quickly. All right. Rate the session too. All right. So do we have, how badly are we over? Why don't you just start asking questions and we'll take as many as we can. Why don't we start passing out the buttons too as the questions come in? Who has the buttons? Yes. Could you go to a microphone so others can hear you? Oh, there they are.
One of the question is for all these, IoT devices,
Yeah.
they put up different versions, right? For example, you just take out earlier. So how you to update your software to reflect the hardware advancements, or even the change of design of the hardware?
So one of the principles that we use in IoT device management is to be able to update the software for it. So are you asking how you can update the software or how you adapt to new changing hardware as it comes out? Okay. As new hardware comes, I mean, you know which devices you're targeting. So let's say, for example, that a new device has AI, hardware accelerated AI, and you want to take advantage of that, right? If you were deploying an application to it or IoT edge workload to it, you simply link that functionality and then deploy it out to it. So it's still like device development.
For example, your application, the software you deploy, maybe the images in memory or
Okay, yeah. So the question was, how do you rationalize over device limitations? The recommended process that we use is to store those in device twins so that you can query them those in the cloud. All right, yep. Go ahead.
So, two quick questions. One is, can you
louder.
it's not, now it's on.
Yeah.
So, can I sideload updates to the OS? Because there are plenty of IoT situations.
Which OS?
IoT Core.
So you're asking about side loading?
I need to be able to I can't just download the OS from the web because these are industrial controllers and things like that. They're not phones, so I can't bring a machine down. I have to have a technician there while they're updating.
So you want to do it manually?
I want to do it manually, and I want to be able to do it through a stick.
Yeah, you can. So you can certainly flash them manually. I mean, it's obviously a time.
So
passing it out to the ones in line?
So
involved
in the
process.
past, we've had to create our own scenario for flashing. Are we still doing that?
Yeah, so we have let's follow up offline, but we do have a way to flash it manually. We're also looking at, for the future, what can we do to allow on-prem control so you can do some more automation there, but still be on-prem.
Yes.
A boring question. Coming from the world
A
of
little louder.
coming from the world of MCUs, I mean, usually we are not talking about support for 10 years,
Yeah.
but longer,
Or longer.
Longer support.
15 years.
So we have the option of going longer. What we encourage is annually an annuity for year by year after 10. We cap it at 15. And best practices in the community, particularly if you have something that communicates, is that if you're building devices that has a 40-year lifetime, you build that you can replace the communication bottle. And the way I'll describe this is, if you look at Wi-Fi, the Wi-Fi protocols we use now are not the ones that we used 20 years ago. So.
What about the cloud counterpart to it? Do you have a lifetime support for that as well?
For which one?
Lifetime. What's our support policy on the services?
Great question. So on Azure IoT Hub, cloud-facing, we assume that we will never, once we introduce a protocol, that we will never break it. The only time that we would issue a breaking change to a protocol is if there was a new security exploit discovered in that protocol. Other than that, they'll keep working. Over here.
So for the Azure
if they're in
Sphere,
line, they can have a button.
Yeah.
If they're in line, they're brave enough to ask a question, they can have a button.
give him one. For Azure Sphere, for the application CPU support, are you limiting it just to ARM, or are you supporting other
For what?
processor architectures?
For what?
For Azure Sphere?
Azure Sphere.
For Sphere.
Initially, one of the reasons we chose to use a Linux kernel is that enables the silicon manufacturers to innovate at their own pace.
Mm-hmm.
The initial partners are all using ARM, but we envision that will change over time.
So for like Microchip, who has the MIPS architecture.
Yeah, we would support that.
Okay.
Yeah.
So, kind of in consumer devices, everything's great with the cloud and you can connect and you can control your device, but do you have anything for bootstrapping, for getting that device to connect? So how do I make it easy for a user to put the Wi-Fi config in? You know, is there something where either there's like an out-of-the-box mode you support, where it'll, an access point and a little captive portal, connect on your phone and put your Wi-Fi. How does the user get their Wi-Fi?
Right now that's very device dependent.
Yeah,
it's a good point.
There's
Once
common
it gets,
patterns, but I was wondering if there's anything in your SDKs that would just be to make that easier? Because it seems to be like everybody's
No,
reinventing the wheel.
that problem has not been solved yet in a general way.
Yeah.
Once it gets connectivity, we've solved the problem of, go
Yeah.
talk
Yeah.
to the device provisioning service. And
I figured maybe like obviously Microsoft, something you can almost build into like most people have a computer or at least a phone, so there's some sort of provisioning.
You're
thing
seeing
you
a
can
lot of
drop on, or-
techniques. A lot of times it'll be like peer with Bluetooth or Wi-Fi,
Yeah.
but yep,
No.
it's
Okay,
not a
thank you.
general solved problem yet. But that's a great question. Yes,
Can I use the DPS?
a little louder, please.
Can I use the DPS service to provision an edge device?
Can you use what?
The DPS
Oh,
service
yeah, device provisioning service with what?
to provision an edge device.
I didn't hear.
To provision an edge device.
Yes, yes, that's coming.
That's coming.
Yes.
Not okay.
Okay, really quick. Integration with logic apps. Is it bidirectional? So can you trigger an event on IoT from a logic app?
Say that a little louder, please.
So
Sorry.
the logic app integration, is it dual way?
Can you issue a command to a
Yeah.
device? Yes.
Okay.
Yes.
It's probably too big of a question for here, but what about IoT in existing manufacturing processes like injection moldings and things like that?
Sorry, it's very loud up here. Could
Oh,
you
sorry.
speak into the microphone a little louder?
Have you guys thought about existing manufacturing processes, things like injection molding, blow molding, that kind of stuff, and incorporating Azure and IoT into those types of processes and machines?
Let's talk after.
Okay.
Yeah.
So one of the issues we've had before was high availability with the IoT hubs. Before we had to create our own system to sort of move the device IDs from one to another if one went down.
Yeah.
I was hoping the device provisioning service would do something like that, but I haven't actually seen documents.
So we have a feature coming for device provisioning service, which is reprovisioning.
Okay.
We also have a feature of customer-initiated failover, so we can fail over from one IoT hub to another. That you can trigger that.
And would it be able to also fail back?
Yes.
Okay. Thank you.
Hi there. I'm a junior from Queen's University, and I just had a question on, you mentioned that it's like an asset to be able to run the software on the device itself, and it sounded like that was less expensive, but if you're running something on the cloud versus running something on the device, aren't you still paying for the computing power either way?
In the cloud?
Like when you move like
Sorry, could you guys keep it down?
when you transfer the machine learning calculations from the cloud to running on the device itself, is that like, is that cost effective? Like how is that how is it cost effective? Because you're still paying for the computing power.
So as an example, so let me take a concrete example. Let's say I'm running Stream Analytics in the cloud, right? It's an Azure service. And then I decide to export a job, a Stream Analytics job, and run it down on a device. It costs less to do that. It is more cost effective to do it on the device. Is that what you're asking? Yeah.
Thank you.
Short answer is it's cheaper. And the bigger reason is because you own the device and you're managing it. Yeah.